Okay, so we are doing 4-7. Again, we're going a little out of order, but this is similar to stuff that we've done before. So I thought it was a good thing to do before we do 4-6. 4-7 is all of these trig functions, and they've got this raised to the negative first. Do you know what that means? When I'm raising something to the negative first? Not reciprocal. Inverse. Inverse. So I'm going to do a little bit of notes about inverse over here. So if you want to join me, I'm just going to jump over off to the side and do a little bit about my inverse functions over here. And remember, if I were to explain inverse to like a 5-year-old, inverse means what? Like, what are we doing when we do the inverse? We're doing the opposite. Let's think of, I like using the word undoes or like going backwards. We're undoing what we've done or we're going backwards. Back in like chapter 1, when we were starting to do inverses for the first time this year, I'd give you an equation like this. I'd say like y equals 2x plus 1. How would you go about finding the inverse of that? Carson?
Switch the x and y.
Very good. We'd switch our x and our y. So we go like x equals 2y plus 1, and then we solve that out, right? So the whole point of inverses is we are switching our x and our y. So we're going to take that concept and put it into this like trig function stuff, okay? So let's think about what's my x and my y when we're doing these trig functions. Let's go very basic with just sine. So if I think about sine, we always do sine of what? An angle, theta or x, right? I'm going to use theta just so that we're in our head like that is an angle. We're talking about angles. And then sine, for example, equals opposite over hypotenuse. It's a fraction. When we do our inverse, we're going to switch it. So instead of my ratio all by itself, the angle is going to be all by itself. Theta is all going to be by itself. And then we'll do our sine to the -1 of my ratio. So I know that this isn't as simple as doing x's and y's, but my angle was, we were doing the sine of it. And then in my second part, the angle is the answer. In my first part, the answer was my trig ratio. And then now the trig ratio is what I'm plugging in. So the biggest thing I'm getting out of here is that my answer is going to be theta or the angle. Okay, that's the biggest thing that we're getting out of this. Something I didn't mention yesterday with alpha, but I'm going to just mention here, it's not going to be relevant to anything we do today, but what we might see tomorrow when we do more practice problems, you'll see sine to the -1. You also might see something called arc sine or arc cosine or arc tangent. That arc is the same thing. It just means like the inverse of. The inverse of. Okay. Now, in order to move from here, we have sine, cosine, tangent, and they are only going to be relevant in a couple different quadrants, okay? So before, if I go back to my notes earlier, back to like 4, 5, so like we've kind of done problems like this, right? We've done problems where my answer has been the angle, and I gave you the ratio or like the number, right? So nothing we're doing today is super new. However, before I said I want every option. If you remember on the test, there was a question, like I wrote the direction on the board. I said, I want all of the angles that are possible. I want both of them. I want as many as you can find. That is not going to be the case here for inverses. We're only going to look in specific quadrants, depending on which trig function we're looking at. So it will not be 2 answers like this. It will only be 1 answer. Okay. And that's going to depend on which trig function we're doing. So we can worry about sine. We can worry about cosine. We can worry about tangent. Okay. Those are the ones that we care about. And each of them have 2 quadrants that we're worried about. I'm just kind of setting it up. Now, what I could do is just say, hey, it's in these quadrants. Know that. Just memorize that. Instead, I'm going to prove it with the graph. If you don't love the graph, don't feel like you have to draw it. Maybe you can just watch me and look through it and just write down the quadrants at the end of it. That's fine. But I'm proving to you why we're using the 2 quadrants that I'm going to tell you. Okay. So let's think about sine. I'm going to think about the graph of sine. So when I draw my graph of sine, you remember sine, where does it start? High, middle, low. Sine, middle. Then where does it go? Up. Then where does it go? Yep, and then,
Yeah.
good. Okay, that's my sine curve. And I could do it in the other direction as well. Okay. Now, if you look at sine, you can even look at your unit circle. We also know, and I'm just trying to I'm literally throwing spaghetti on the wall and seeing what's going to stick for you. We know that we've got all students take calculus, right? So sine is positive where? 1 and 2, right? So sine is positive right here between 0 and 2 pi over 2. You guys good with that? It's also still positive up here before I get to 180. Okay. I can't look at quadrants 1 and 2 to tell me sine because they're both going to be positive. It's going to be confusing. I'm not going to know which one's the right answer. So instead of using quadrant 2, we're going to actually go backwards and we're going to use quadrant 4 because sine is negative in quadrant 4. So when we're looking at sine and I say we're doing the inverse function, you care only about quadrant 1 and quadrant 4. Those are the places that you're going to look for answers. First.
Might not be the best time, but can you explain
The quadrants? Basically, and I thought I explained this well, but I was talking to Ms. Ludington the other day, and she's like, my kids just kind of got this, so maybe you guys don't get it yet. Basically, what happens is this is an order, this is a coordinate plane, right? So in quadrant 1, both the x and the y are positive, right? We know that sine and cosine go as x and y. Sine is your y, and then cosine is your x. So basically, that's telling me my cosine and my sine are both positive here. And then we know that tangent is y over x. And if you have a positive divided by a positive, that stays positive, right? So that means all of my trig functions are going to be positive up here because we're in quadrant 1. The minute we go to quadrant 2, now those points go negative positive, right? We go left, so that makes it negative, but we stay up, so that keeps it positive. Is everybody good with that? Now that means now that my x or my cosine is now negative, but my sine stays positive. When I think about tangent then, if my x is negative, a positive divided by a negative is still going to be negative. So the only thing that's positive in quadrant 2 is going to be that y value or your sine. Because sine is positive in Q2, so that doesn't give me a new or unique answer. Sine is negative in quadrant 4 because it goes positive, negative. That's my y value is always negative down there. So these two quadrants give me an example of a positive sign and an example of a negative sign. Quadrant 3, if they're both negative, that means that both cosine and sine are negative, but when you do a negative divided by a negative for tangent, tangent's the only thing that's positive. You guys kind of get a couple light bulbs or a couple kids who are like, oh yeah, I knew that. Person, does that kind of answer your question? I think you're jumping ahead. I don't think I'm ready for that question yet. So sine, if we only looked at quadrants 1 and 2 in sine, they're both going to be positive. And that's not helpful information. It's the same answer, and I don't know which one to pick. So I have to pick a different quadrant to look in. And so we do 1 and 4 because they're the ones next to each other. And so if I have a positive sign, I know I'm looking at quadrant 1 for my answer. If I have a negative sign, I know I'm looking at quadrant 4 for my answer. Q3 I could, it's just not next to it. So all of these you're going to notice are going to be next to each other. So cosine, when I think about cosine, I am going to do 1 and 2 because cosine is positive in 1, but it's negative in 2. And again, I can prove that with the graph. So if I jump over here and draw like a tiny graph of cosine, we know that cosine starts high, then goes middle, then goes low, then goes middle, and then goes high. So it looks something like this. And on the other hand, while sine is positive and then positive, cosine is positive in quadrant 1, but negative in quadrant 2. So I'm getting unique different answers by looking in Q1 and Q2. If I were to look in Q4 for cosine is positive there, so that's not going to give me a new number. I don't want to look there. Joey.
For the sine graph you drew, the quadrants you have highlighted are those 1 and 3?
1 and 4.
So that's 1/4.
Yes, because I'm going backwards. Think about if I'm I'm like drawing all these little things that I'm gonna erase in a second. Think about if I'm over here in quadrant 4. You can get it by going all the way around, or you can get it by being at 0 and going backwards, negative angles. Remember when we talked about coterminal angles being minus going in the opposite direction? That's what we're looking at here in Q4. And then last when we do tangent, we're going to do it the same as sine. It's going to be quadrant 1 and quadrant 4 as well. And again, if we look at our picture of tangent, tangent was one that I didn't ask us to know a ton about, but it starts at 0 and then it kind of cubic graph through, and at pi over 2, I have another vertical asymptote, and then at pi, I get another one of those, etc., etc. Tangent is one that we don't cover a lot about, so I just remember tan and sine have the same quadrants we look in. Tangent and sine have the same quadrants we look in. You don't ever have to prove this. I'm just showing you that I'm not just making this up. I'm showing you that there's a reason why we look in 1 and 2 or 1 and 4. What you need to do from now on is just know which ones we're looking at. So like when I do sine, I'm thinking only in Q1 and Q4. So sometimes I would take my unit circle and I would fold it in half and I would get rid of quadrant 2 and 3 just so I didn't have to look at it. And I would only look at 1 and 4. When we do cosine, I only care about quadrants 1 and 2, so I'm only looking at the top ones. This is a very similar process of what we've already done. I'm just eliminating one of the option answers. You only give me one answer here, okay? So why don't we look at this? Let's try it, okay? So these all say inverse sine, which means my answers are all going to be in angles. And it says that we want them to be in radians, okay? When I look at my unit circle or when I think in my head, I'm doing inverse sine of root 3 over 2. Well, we know that sine is y. And so what point has a y of root 3 over 2? 60, good. I am in quadrant 1. I'm not in quadrant 4 because why? It's positive. And so that's my 60-degree angle. The only thing is they want it in radians. So what's the radians of 60 degrees? Pi over 3. So pi over 3 is my answer. Okay, same idea for letter B. It's also sine. So that means I'm still looking at my y. However, which quadrant am I looking in now? Because I want to do inverse sine of negative 1/2. 4. We're looking at quadrant 4. And so what in quadrant 4 has a negative 1/2 y? 330, good. And what is that in radians? 11 pi over 6. Very good. Good.
Wait, and then why did you know it was a question?
Good, because it's negative, and sine is only going to be in Q1 or Q4, and Q4 is where it goes negative. Before today, we would have looked in quadrant 3 and 4, and I would have given 2 answers, but right now I only care about the 2 quadrants that I have listed up here, so you only give me 1 answer. All right, let's go to letter C, inverse tangent of 1. Ooh, tangent we know is y over x, and you might have done this enough times that you know that tangent being 1 is coming from what angle? What angle gives us a tangent? 45. So we are in quadrant 1 because tan is positive. And what's my radian for 45? Pi over 4. Yeah, Carson.
How do you know it's
The only way to get 1 when you have your x divided by your y is having the same number on top and bottom. So if you think of your unit circle, all your answer possibilities, we have, I don't even know if I have a unit circle in here. Let me pull it up. So if we look at all of our answer possibilities, the only place where I have the same answer for both your x and your y is 45. Now, a lot of people want to do your quadrant angles because there's 1 involved there. But if I do 1 over 0, that's undefined. Or if I did 0 over 1, that's 0. So you want the x and the y to be the same. What'd you say?
like when they're in the parentheses?
When it's tangent of 1, we want the x over y. If it's sine or cosine, then you're looking for the x or y, but tangent here is y over x.
So And these don't really use the AS.
Because we kind of already eliminated it by coming over here and deciding already what we're doing. All right, and then last one like this is inverse cosine of 0. Cosine is x, and so we want to know where's my x 0. And again, I'm only looking in quadrants 1 and 2. Here's your x 0. 90 pi over 2.
Oh. The tangent for C, if it, was it to a negative, would it be 1/4?
If it had a negative right there, then it would be in quadrant 4. So we got a tiny taste of this. We're going to do more of this tomorrow. I've got more practice problems on this, but one set of directions I can do for inverses is using basically our unit circle / our brain to figure out the exact answer in radians, okay? The next problem is where we use our calculator. This is going to be a little bit easier for us, right? So get those graphing calculators out. It says use a calculator and solve and round to the nearest 10,000th degree. What mode should you be in your calculator if it wants the answer as degrees? Degree, right? Talk in the same language as you enter into your calculator. So I am going to make sure my calculator is in degrees, and then we're going to work on plugging this in. Let me do something really quick. So I have my calculator. I'm literally just going to plug this in. Do you know how to get sine to the -1? Second tan or second sine or second whatever. Very good.
There can be a calculator and non-calculator for it.
There will be on this test. Second tan -1.43. Now this answer is -55.0349. Okay. Have we done a ton with negative angles? We've done a little bit with the coterminals, but I don't want you to leave this as a negative. What quadrant am I in right here? 4. So I am basically, and you don't have to draw this picture, but I am basically here. And instead of counting me going all the way around this way, we went this way and said we're at -55, blah, blah, blah. How would you go about finding out what my positive angle is here? Let's add it to 360. Because it's already negative, let's add it to 360. So we're just going to say plus 360. And I haven't even entered it out of my calculator. I'm just going to go plus 360, and 304.9651 is my answer. Bless you. If it is not a negative angle, you don't have to do any of that. But if it is negative, we got to make sure it's positive. Oh, nice. Did I answer your question? I love when I do that. All right. Should we look at the next one? All right. The next one says inverse sine of 0.761. Go ahead and enter that in. Do I have to do anything to this number? No, it's already a positive number. It's good to go. It's in quadrant 1. We know exactly where we're at. Once you get that one, move on to the next one. Ooh, now this one says secant. Okay. Secant goes with which trig function? Cosine. Good. So I can think of this as inverse cosine. And if instead of doing secant, which is 1 over cosine, and I flip it to just be cosine, when I do this next part in the calculator, I'm going to go 1 over the answer that they gave me. So I'm going to essentially think of that as a fraction, and I'm going to flip it. So instead of writing it like 1.98, I'm going to make it be 1 over 1.98. Okay. So second cosine 1 divided by 1.1. So I get 59.65. 9.665. Do I have to do anything with that, or is that one good? Sounds good, right? All right. Perfect. So that's another set of directions we could do. We did unit circle, we did calculator, and then these last four are all by hand. We're gonna do these by hand, and this is gonna look a lot like certain problems that we've done on the last test. Okay, so we're gonna start it here and be like, oh my God, we've done a million like this. Exactly, this is just a slightly different direction, okay? So let's look at this first one. It says sine inverse tangent of 0.1. First thing I want to do is make that 0.1 a fraction. So what would be 0.1 as a fraction? Would you say? Yeah, 1/10. Very good. Okay, so that's the same thing as 1/10. So we're saying inverse tan of 1/10. That means the tangent of the angle is 1/10. So tangent, we know, is in terms of opposite over adjacent. I don't at all care about the angle here. I never once asked for the angle, so I don't want to find the angle. What we're going to do is we're going to graph a picture. We're going to do our little coordinate plane. If tan is positive 1/10, what quadrant am I going to draw in? Quadrant 1, right? Good. So since tan is positive, we're going to draw our triangle on quadrant 1. My theta goes down there at the corner. And again, I don't care at all what that theta is. I just want to know what sine of that theta is going to be. And we know tangent is 1/10. Opposite over adjacent. Now, if we want to find sine, though, we need that hypotenuse. Can you find that hypotenuse of that triangle? Oh, yeah, easy. Do that Pythagorean theorem. So 1 squared plus 10 squared equals x squared. 1 plus 100 equals x squared. Plus 2. And as much as I wish that root 101 simplified down, it does not. And now that I have my pieces, we can do sine easily, right? We can do opposite over hypotenuse. I will make it rationalized, so I will make it root 101 over 101. But that would be my answer right here.
We should do that.
Because it would be 1 over root 101. And I rationalize by multiplying by root 101 on top and bottom. Why don't we do, why don't you try letter D without me? Letter D is pretty easy. Why don't you jump to do letter D without me, okay? We'll come do the other ones, but letter D, I know you can for sure do without me. Try that. Yeah, good question. That letter D on the board, feel free to check in with that when you need it. When you're ready. The other two are super similar. They just have like some cosecants and secants and stuff like that. Make sure that you handle those as we would. So like if I jump up, because I can still see letter B and letter D at the same time, it's pretty simple to do your sine. The secant part, you just have to remember that's the reciprocal of which one? Secant is the reciprocal of cosine. I'm gonna work through that in a second, so if you wanna join me, I'm gonna go up to letter B next. Yes, Francis. Quadrant 4, because sine is negative. And sine only goes, inverse sine only goes in 1 or 4, and 4 is when it's negative. Maddie, question.
How do you know which one on the triangle is like negative? You have negative.
Great question. Since the hypotenuse is never negative, so it's either opposite or adjacent. All right, I'm gonna jump and do letter B, so you can go ahead and start drawing your picture. Labeling sine with opposite adjacent hypotenuse. Graphing your triangle. And then finding your missing side. Got letter B up on the board. Are we feeling okay about this? All right, go ahead, do letter C on your own, and then the last thing we'll do is just confirm that we can do this in the calculator. Yeah. So one more time. Oh, you look at the parentheses. So whatever the trig function is attached to. So like in this case, we'll look at cosecant to decide if it's positive or negative. The one before, oh, that's positive, so it doesn't matter. This one, because it's attached to the sine, we'll do it from sine. Find that we do a lot of the same Pythagorean theorems, so if you're like, oh, I recognize we just did these numbers, you don't have to redo them. That's the simple way. So again, this looks like problems that we did a ton of different ways in the first part of this chapter, right? I would give you an ordered pair and we would do something like this. I would give you cosine, I'd say sine is negative. We've done this like several different ways, and now we have the same process, just a new set of directions essentially. But at the end of the day, I'm just drawing my picture, I'm doing Pythagorean theorem, and then I'm finding the trig function they want from me. The last thing I want to do is plug this into our calculator. And when I go to plug this into my calculator, it does not matter what mode I'm in, because never once do I enter an angle. So because I never once put like 30 degrees or pi over 7, I don't care if you're in radians or degrees, okay? We should all be in degrees because that's what we have been in. But we are going to go ahead. So I'm going to type sine second tan 0.1, close all my parentheses. that gives me a crazy decimal, that's okay. But when I go plug in root 101 and then divide that by 101, that should be the exact same number. So do you see how we're getting the same number each time? Same number each time. So why don't we go ahead and try that for the next ones? This one's secant. That one's a little bit confusing. How do you think I put secant in the calculator?
Whatever.
1 over cosine. So I'm gonna make this be 1 over cosine, and then we'll do sine to the -1 of 2/3. Just make sure your whole denominator is in parentheses. So I'm gonna do 1 division parentheses, and then cosine, and then second sine, and then 2/3, and then close all of my parentheses. And then I can do 3 root 5 divided by 5, and I should get the exact same number.
Just had a big one.
And we're just checking our work. Doing it on the calculator. So this part could be on a calculator or a non-calculator version. I'm showing you that you can do it both by hand, and then we can check it in the calculator. While I'm here on letter B, let's just jump down to letter D because that's an easy plug-in. We'll go cosine, second, sine, -1/5. And then I'll do 2 root 6. Ooh, not bad. 2 root 6 divided by 5. Yep. And that should give me the same number. Then I got one more. You guys okay with this? Okay, I'm just trying to show you how to use your calculator. Now this last one, we go ahead and plug this in. I'm gonna keep my tangent as is, but that cosecant is gonna be the reciprocal of what?
Fine.
Sine, good. I'm gonna use sine and I'm gonna go ahead and flip that fraction. So when I can, I'm gonna flip the fraction. If not, then I'll do 1 over sine, but I prefer not to. So I prefer to keep this as is. So I'm gonna press tan, second, sine, 2 divided by 3. And when we do 2 root 5 divided by 5, I should get the same answer. Get the same thing. So now we've just taken all of the problems we just did and checked them in the calculator. That's all I've got for today. So we are going to pause. I'm giving you a little less time than last class, but we had some big questions at the beginning. We're going to work on 4-7 and 4-8 homework. That's going to be due next time I see you, which I believe is tomorrow. We got 17 minutes to get started on that, okay? Any big questions? Yeah, Maddie? Yeah, I'll come over and help you with me. Any other big questions for the good of the group? All right, let's work on that homework.